my name is Anaiya Raisinghani, and I am here today on behalf of MongoDB to run you through a super fun tutorial. I don't know about you, but the past couple of months have been crazy. There's been super weird friend group drama. My friends have had their situationships or their relationships end. I've had really weird experiences where a bunch of my packages were actually getting stolen and then returned. So it was a lot of calls to FedEx and my landlord just to be like, oh, never mind, it's actually here. It landed outside my house. Every single hangout session in the past couple of weeks has ended with, I don't know what's going on, but something is in the air. I have a question for you all of my watchers. What if something isn't in the air, but rather in the stars? So let's use TensorFlow and MongoDB Charts to analyze 6 months worth of horoscope data to figure out if these mishaps and all of this confusion is just up to chance or if they are truly written into our destiny. In this tutorial, we will use machine learning to perform sentiment analysis on our horoscope datasets. We will use TensorFlow to build out and train a model using that dataset to see if things will get better in the future. And then we will be using MongoDB Charts to help ourselves visualize everything along the way. Before we get started uncovering our future, let's just jump into some of the super important platforms that we are going to be using throughout this tutorial. So the first one is TensorFlow, and TensorFlow is actually an open source library that developers can use to conduct all sorts of machine learning tasks. It was developed by Google Brain and is used all across the board by developers and data scientists alike for a multitude of projects such as natural language processing, image recognition, voice recognition, and so much more. So TensorFlow will actually allow us to build out and train our machine learning model to let us know whether our horoscopes are either positive or negative, meaning that we can have insight into both our past and our future horoscopes. MongoDB Charts is a tool inside of MongoDB Atlas that allows for developers to very easily visualize the data that is stored inside of their collections. The greatest part about Charts is that it has real-time visualizations as their database evolve and change. This is super perfect for our project since it will help us better to understand and visualize our data as we work through our tutorial. In order to be successful with this tutorial, you will need a handful of prereqs. The first one is a basic understanding of TensorFlow and a willingness to learn more as we go on. An IDE of your choosing. This tutorial is actually using Google Colab, a MongoDB Atlas account, MongoDB Compass downloaded locally, and then the related dataset from Kaggle. And everything will be located in the description box below. So once your MongoDB cluster has been created, we are ready to begin. Our goals for this tutorial are to use a pre-trained model to generate labels for our dataset, and then we will actually train a model from scratch using our label dataset. So just keep this in mind as we are going through. Let's get started. All right, so to save us some time, I actually went ahead and scraped all of the daily horoscopes from January 28th, 2024 to and including July 28th, 2024 for all 12 zodiacs, and then I saved them into a file with the date, the zodiac name, and the horoscope itself. So these dates were just chosen because they're from about 6 months before from when this tutorial was actually created. And so all of the documents that you're going to need for this tutorial are located in my Kaggle account, and I will link them in the description box below. So we have 3 so far, but I'm going to take you through how to build them out. So let's start with the first one, which is just Anaiya 6 months horoscope sentiment.csv. So then once we have this and once you have it downloaded to your machine, we can go over and we can actually put them into our Google Colab account. So to do that, just go over to the side here and we can upload it. And once it's been uploaded, you'll be able to see it inside of your Google Colab file. And it'll just look like this. And as you can see, there are over 2,000 entries of all of our horoscopes, which is super exciting. So that we have our data set on hand, the first thing that we want to do is we want to figure out each horoscope's sentiment using sentiment analysis. So sentiment analysis is a way of figuring out emotional tone from a piece of text. We are only going to be classifying our horoscopes as either positive or negative. We aren't going to worry about any that are neutral. And luckily for us, at this point in the tutorial, we actually don't need to build a model yet. We can use a pre-trained model to figure out whether or not our horoscopes from the past 6 months are positive or negative. So we can get started with that here. First, what we want to do is specify our imports. And the most important one that we have is the transformers library from Hugging Face. So this one just includes a ton of pre-trained models that can actually help us figure out text classification. We also want to go ahead and import in our TF auto model for sequence classification. And then we also want to include the auto tokenizer. Then from there, we just want NumPy. And we also want to include SciPy Special, which includes softmax, which is a library that we're going to be using. And then, of course, we want to import TensorFlow because that is how we are going to figure out with our new horoscopes if our upcoming week is going to be positive or negative. So let's just run that. All right, so once everything is imported in, let's choose which pre-trained model we want to use. Since this is a TensorFlow tutorial, we can actually just go ahead and use the Distilbert base uncased fine-tuned SST2 English model since it's compatible with TensorFlow. But there are a ton of options out there to choose from if you would like to switch it up. So in the code that we're going to be writing now, we're going to be loading in our pre-trained model and then the pre-trained tokenizer, config, and model from our transformers library. So let's do that. And then our tokenizer, and this is just bringing it in from pre-trained Distilbert, and then our config. And then we have our model. Perfect. And then, so pretty much what this does is the tokenizer is going to convert our text into IDs, config holds all of our configuration information, and model is our pre-trained model loaded with TensorFlow. Now let's write a function to find the sentiment of our text by taking in the text and tokenizing it, and then finding the probability of the sentiment by using the softmax function. Then the highest probability is categorized and saved. Let's go ahead and write this function. First the input. And then we also want to include the max length of 512, and then return tensors equals TF. And I will be including all of my resources down in the description box below. If you have any questions on where some of these elements are coming from and the research that I did going into this tutorial. And this is where we're using our softmax function, and then ranking Please make sure that this is a -1 and not a 1, because if you miss that, everything will be positive and it won't recognize negative sentiments, which is something that I learned the hard way. All right, so now let's go ahead and test and see if this works before we try it on our CSV file. So I'm just going to do a random horoscope, and I'm going to make sure that's on the negative spectrum of things. So I'm just going to copy and paste it from my written tutorial, which will be included in the description below as well. All right, so this is saying, things might get a bit confusing for you today, Capricorn. Don't feel like you need to make sense of it all. In fact, this task may be impossible. Just be yourself. Let your creative nature shine through. Other people are quite malleable, and you should feel free to take the lead in just about any situation. Make sure, however, that you consider other people's needs. So I understand, and this is a little bit of something that I feel like I should say. I do understand that horoscopes are meant to be slightly vague, and keep that in mind when we're going through this tutorial. A lot of the times you're not going to have a horoscope that is fully negative or fully positive. So a lot of our horoscopes will kind of fall on kind of a boundary, like a 0.5 boundary, which will make more sense when we get into the actual TensorFlow model building of things. But just keep in mind, like, it's not going to say your day is going to be absolutely horrible, Capricorn, just because horoscopes don't really work that way. So keep that in mind. Sometimes things might be a little finicky, but that's just because of the data we have on hand. And now let's just do a little print statement. Horoscope is sentiment. All right, let's run this and see if it's able to correctly let us know that this horoscope has a negative sentiment. And it did. That's awesome. So this works. So now we do need to make some changes because we don't want to put in every single horoscope manually as individual strings. We want to do two things. We want to use this pre-trained model, put in our .csv file of all of our horoscopes, and figure out the sentiment analysis of each horoscope in our file. And the second thing we want to do is we want to incorporate a new sentiment column that will include 1 if the horoscope is positive and 0 if the horoscope is negative. We are doing this so that when we get to the part where we build out our actual model, we can use a new file with horoscope data and sentiment analysis to train our model on a completely new set of horoscopes that our model was not previously trained on. So let's first write out a function to apply each sentiment to our horoscopes. Apply sentiment. So this is just saying that to return a 1 if it's positive, and then if not, return 0. And I like to run everything as I go just to make sure if we have to debug at the end, or if we have to debug at any point, we catch it before we're too deep. So now we need to load in our Anaiya 6 months horoscopes .csv file, and then make some changes to our data frame. So we have to use the pandas library. Let's go ahead and install that because we haven't done that yet. Perfect. And now we can read in our file. And then when we apply each sentiment, we actually do have to make sure we have a column to hold them. So we can just set that up pretty pretty simply. Cool. Let's run that. Okay, so that is going to take a long time. That took me over 11 minutes, but it makes sense because we are applying our pre-trained model sentiment analysis to every single horoscope that we have in our file. And since there are over 2,000 horoscopes, it's going to take a while, especially if this is the first time you run it. So once that's done, our last step for this part is to save our new data frame to a new CSV file. Please feel free to call it whatever you like. I'm just going to call it Anaiya 6 months horoscope sentiment.csv. That's what I'm going to call it. Okay. And then we can just do print save to new file. Perfect. And if you're using Google Colab, you can see our new file on the left-hand side of the screen. And if we open it up, we can see that everything has its own little sentiment column, which wasn't there before. Perfect. So now let's head over to MongoDB Compass, upload our .csv file, and then visualize our data in MongoDB Charts before we use this data to train and test a model using TensorFlow. So the reason why I want to use MongoDB Compass is just because it's great at taking in CSV files. So we can just use it to our advantage and upload everything that we want to upload. And this just saves us a couple lines of code. So if you have it downloaded locally, please feel free to use it. And we can just create a database name and then a collection name. So we can just do I'm just going to do horoscopes and horoscopes for each and then create the database. You can name it whatever you like, but I feel like at this point it really doesn't matter. And then we can go over here, add data, and then we can import our CSV file that we have downloaded. So as you can see here, this is what our file looks like. And we want everything. Yeah, I guess we don't need the first column. We want the date, we want the zodiac, the horoscope, and then the sentiment, of course. So let's go ahead and click import. Awesome. Once this has all been imported, we can head over and visualize everything in charts. So I'm already in my my cluster, and let's go and make sure that everything got correctly imported. Hit browse collections. Great, we have everything we need. So now what we can do is we can go over to charts up top here. Now we can select our data source. We can go over here and click add dashboard, horoscopes dashboard, save. Okay, add our chart. We can select our data source. There we go. Click on horoscopes and then select. And we want to keep it as a grouped column. And then we want our x-axis to be our zodiac. We can just drag it in. We want the value to stay like that, sort by value. We want our y-axis to be our sentiment. And we want to do count by value. Cool. So from this chart, we can see that there are a lot more positive horoscopes in our data set rather than negative ones. And we can actually create another chart to showcase this amount. Let's go ahead and do that. So here's another chart that we can do just to see our positive versus negative. And as we can see, there are 73% positive horoscopes versus 26% negative horoscopes. So this is great news because it does show that, the stars aren't against all of us. From our chart too, from our previous chart, we were able to see that Pisces and Leo have been thriving. Let me go ahead and redo that for us. So as we can see here, Pisces and Leo have actually been thriving these past 6 months, whereas Scorpio has really been getting the short end of the stick. So this gives us really great insight into how our data is skewed, as it's crucial to visualize your data prior to training a model to make sure that it's balanced and that our model is learning correctly. From our visualization, it is clear that our dataset is unbalanced, which means we are going to have to go through a couple steps to ensure we are feeding our model with a proper training set. More on this below in a different section where we're going to actually balance our dataset. Now that we have an idea of the data that we're working with, let's get started on training and testing our model in TensorFlow. So we're going to be using this data set to train and test our model to see that if we are able to incorporate new horoscopes, for example, a weekly horoscope that isn't in our trained data set, we can see if they are positive or negative. Our first step is to import our TensorFlow hub as hub. Run that and make sure it works. And then we can load in our new CSV file, but we only want to focus on the columns that are horoscope and sentiment. We don't need the date or anything else like that. So df pd read CSV, Anaiya 6. And then df and all right. Once we have that, our next step is to actually split up our sentiment data set into 3 separate sets. We need a training set, a validation set, and a test set. Now, this is where we need to make sure that our data set is balanced. So this is super important because we need to make sure that our model is trained on the same amount of negative and positive horoscopes. Otherwise, our model might only be trained on positive horoscopes and it won't learn to recognize negative horoscopes or vice versa. So first, let's go ahead and shuffle our data set. And this just shuffles everything that we have. Now let's go ahead and split our columns into X and Y variables. Perfect. And all my resources are going to be in the description box below. If you want a better understanding of balancing your data set, that's where everything will be. So now we need to include some helpful libraries so that we can achieve this, especially because we are conducting random undersampling. All right. So random undersampling actually allows us to remove random horoscopes from the majority class or our positive horoscope class to ensure that we have a more equal distribution of positive and negative horoscopes that our model can actually learn from. Now let's do for training and testing. So X train, X test, and Y train, Y test. Now I want to create our random undersampler object. And once again, since positives are majority, we want majority. And then we want to apply our random undersampling technique. So now let's convert it back into our data frame. So balance trained. Let's go ahead and run that, make sure we don't have, oh, we have an error as this needs to be. And this is because I believe I'm missing that. Oh, okay. Okay, there we go. All right, so once this has been completed, let's just check and make sure that we have the same number of positive and negative horoscopes in our training set. So sentiment, amount, training. Value, counts. Okay. Oops. I don't know what happened. Counts. Okay. And then we can just print out our sentiment amounts. Yeah. All right. Let's print that. Awesome. We have 495 positive horoscopes and 495 negative horoscopes. Now that we see that, we can actually go ahead and split up our data set into our 3 separate sets for a TensorFlow model. And we can do this now because it's balanced. Once again, they are our training set, our validation set, and our test set. And you can split it up into any percentages that you like. But it is recommended that you do an 80% training split and a 20% validation split. So this is going to be 20%. And this is sentiment, and then random state equals 42. Run that. Okay, those closing brackets are really getting me today. There we go. Okay. Okay. Nice. So now let's just quickly view the size of each set, just to make sure that we're happy with the distribution. So we can just set them up like this. And I'm just going to do validation set. And this one is our test, and we want val here, and we want x test here. So let's print it and let's see. Awesome. So we have 792 in our training set, 198 in our validation set, and 330 in our test set. Now, the next thing that we're going to do is very important. We actually need to combine our x test and y test back to a data frame so that our column labels are back in place when we convert it to a TensorFlow data set, as they were removed when we balanced everything. So that's just one little line and everything will work, hopefully. All right. Perfect. Let's move on. Now, we need to convert our data frames to TensorFlow dataset so that we can properly load it into our model. So we have to do this because it converts each train, validation, and test dataset into a TensorFlow dataset. So it'll actually shuffle everything again and then batch the data for you, which is fantastic. And once again, I found this through one of my really great resources, so I will include that in the description box below. All right. Let's run that, make sure it works. And now once again, we can just go in. Sorry, lots of typing errors today. All right. Just to make sure that everything has been TensorFlow-ified, let's just write one line to see what our train data actually looks like. So let's just list it. Okay, great. That's what we want to see. Now let's embed and let's build out our model. So the embedding layer that we're going to be using is from TensorFlow Hub, and you can do this step manually yourself, but there really is no need to reinvent the wheel. We can just do this into very simple lines, just like this. Hub.dev. And then our hub layer. So please keep in mind that this trainable true ensures that these layers also get trained along with the rest of the model that we are building below. So what does this do? This embedding layer actually converts our text into embeddings for the model to better understand, as machines don't understand text, only numbers. Since we are using the NNLM-NDIM52 layer, we are just producing 50-dimensional embeddings for English words. All right, so now that our embedding is in place, we can get started on building out our neural network, TensorFlow model. We want various layers here built using our sequential model, since it's a way of stacking the layers one by one, and it is the easiest model to understand and visualize. let's get started really quickly with that. So we have our model, and it's sequential. And then we can do model add help layer from above. And now we're going to do dense layers. And we're using dense layers because they extract and learn complex patterns and features from the embedding vectors and then pass them on to the next layer. So our first dense layer is going to look like this. All right, and then we are going to be using dropout layers as well. So let me add it in and then we'll talk about it. So dropout layers are great because they actually prevent overfitting, which can lead your model astray and provide inaccurate results. So in this, in totality, we're going to be using 3 dropout layers, and the first of them is going to be 0.4. Then let's add in another dense layer. So this is our second dense layer. And this one is going to be 64. And then we'll have another dropout layer. And this will be 0.3. And then we'll do one more dense layer. And this will be 32. And then just one more dropout layer. And so you can play around with this, all of these numbers, the amount of layers, whatever you want to do to fine tune your model. So we might need to do some fine tuning. As I was building this is the model that worked for me when I built it. But of course, every single time we go through this, we rerun everything and we redo our sentiment analysis from the beginning and everything gets reshuffled, things can definitely move around. So we'll go through that after, but this is what worked for me before. So let's try it and see what happens. Then after that, we can just do model add tf keras layers dense. This is one more dense layer, but it's actually the output. So for this, for the output layer, we want to use our activation as sigmoid because it's really great for binary, which means that it's perfect for sentiment analysis because we're just working with ones and zeros. Let's run that. Perfect. Let's now go ahead and compile and run our model. So we'll do model compile. And for our learning rate here, I'm just doing 0.0001. And this too, you can do a different learning rate and you can play around with that as well, as you'll see as we go on. And then we want to include our loss. And then metrics. Perfect, so let's run that as well. Great. And so a little bit about the learning rate. The reason why I'm using a learning rate that's so low is because changing your learning rate changes how frequently your model's weights change to truly optimize your model's performance. But play around with it and you can see whichever one works for you. It's normally a very low number between 0 and 1, and it actually has influence on how quickly the model learns. So we might be making some changes to that, but we will see. So once our model has compiled, we can actually go ahead and train our model on our training data while using the validation data to check how well and see how the model is doing on previously unseen data after each epoch or a single pass through the entire training cycle. Just go like that and go history, model, fit, data. And then for this one, I'm just going to keep it kind of low. I'm going to do 5 epochs because we have a lot of information. and we don't want it to take too long, but you can also go ahead and adjust the number of epochs, and that'll tune it a little bit better as well. Let's run this, and it'll take some time, so I'm going to pause it and then come back when it's finished. All right, so our 5 epochs have finished running, and we can actually learn a ton about our model from the output. So here we can see that our loss decreased from 69% to 68%. Our accuracy increased from 49% to 53%, and then our validation loss decreased a tiny bit from 68% 0.99 to 68% 0.24. But our validation accuracy, which is pretty much the most important part, went from 58% to 67%. So it's great that we have decreases in both our training loss and our validation loss. And a decrease in training loss means the model is improving based off of the training data, while a decrease in validation loss means the model is generalizing well off of unseen data. So validation accuracy at 67% is fine. To improve this number, we would probably need more epochs, a larger training set, more layers, etc. So have fun fine-tuning and seeing your results with these changes. I'm not going to go through that right now because this should be fine for what we're trying to do. But if you do want more accurate results, I recommend fine-tuning, reshuffling your data, using way more epochs, maybe like 15 to 20, using a different learning rate, just playing around with it and seeing your results. So let's quickly evaluate our model on our test data set and check the overall loss and accuracy. Great. So our loss is 69% and our accuracy right now is 47%. So, I mean, that's not great, but it's kind of expected because our data set is relatively small and we only use 5 epochs. So instead of focusing on this part, we should focus on the fact that our validation accuracy has been increasing with each epoch and its loss has been decreasing. But let's go ahead and see if we can use our model to predict the sentiment of unseen horoscopes. And depending on if it correctly can predict a positive and a negative horoscope, then we can go back and make changes and fine tune a little bit more. So let's do that by just doing a little function. Sentiment. So let's convert everything so TensorFlow can understand it. Let's do encoded input. So now let's figure out the prediction from the probability, and this can be easily done with TF squeeze. That did prove to be the hardest part of figuring this out for me, but finding that made things a lot easier. So I'll leave documentation below as well if you're interested in learning more. And we can just print it out just to see what it looks like. All right, so now let's set it to see if it's negative or positive. And we're just going to be using our boundary, which is 0.5. So positive horoscopes are closer to 1, negative horoscopes closer to 0. So now let's go in and do a positive horoscope, one that our model has never seen before. So let's do a positive horoscope, and then we'll do a negative horoscope as well. So I'm just going to say for our positive horoscope, you're incredibly productive with good business sense, Libra. And then for our negative horoscope, we are going to do, this isn't the most cheerful time, Leo, because important issues are rearing their heads again and forcing you to address them. All right, and then let's print it out. So this should be positive, pause sentiment, and then this should be negative neg sentiment. And let's see what our model gives us. Awesome. So it lets us know that the positive horoscope is in fact positive and the negative horoscope is in fact negative. So it seems that our model is properly tuned, or tuned enough to understand positive and negative sentiment. And once again, I just want to include here that, as you can see, these are both very close to the boundary. This one, the positive one, is exactly on the boundary. The negative one is a little bit below the boundary. And that's because the data that it was trained on, they're horoscopes. So a lot of horoscopes, once again, are up for interpretation. So it is expected that they're on the boundary, but it correctly predicted it, which is fantastic. So now we can ask ourselves if things will get better in the future. For this part, I've actually saved the upcoming weekly horoscopes from horoscope.com for all 12 zodiacs. And we're going to go into my Kaggle and grab that file and then upload it once again into Google Colab. So I'm going to just do that really quickly. All right. So once that's been placed in, and you can open up that file and see it here. So this file doesn't have any sentiment analysis column. We haven't done that on this yet. Our model has never seen it. Our pre-trained model has never seen it. These are all new horoscopes. So let's run them through our model and then see the output. So here I have horoscopes to CSV, and then so this is saying that we want to predict the sentiment for each. This is the same thing that we did above, so it should look pretty familiar. Apply and predict sentiment. So for each zodiac, we want to see horoscope is positive or negative, so sentiment. All right, let's run it and see what happens. All right. Now that we have it, let's save it into MongoDB in the same database we created in the beginning of our tutorial, but under a new collection so that we can use MongoDB Charts to visualize our new horoscopes. So first, what we want to do is we want to install PyMongo, which is our Python driver. And then we want to connect to our MongoDB Atlas cluster and write in our data. So once again, we're going to be using getPass to do so. And please make sure that you have your connection string on hand because we need that. connection string, and then client. Connection string. So once again, creating a new collection in our database. So I think we had, yeah, I'm pretty sure it was horoscopes. And our old collection was horoscopes. So our new collection is going to be called New Week Horoscopes. All right. Zodiac and horoscope, and then sentiment is sentiment. Great. And then we can use our handy little insert one for our new dictionary, and then we can print it as whatever saved. Cool. And I'm going to go put in my connection string and then be back. Perfect. So it says that it's saved. Let's go and see if it has been saved. Perfect. So here we can see we have our new collection, which is New Week Horoscope. And then we have our horoscopes with our zodiac, the horoscope itself, then the sentiment. Perfect. Great, so now that we have everything saved in our New Week Horoscope in our new collection, and as you can see, we have the zodiac name, the horoscope, and the sentiment itself for all of the zodiacs, we can actually go ahead and we can visualize this in charts. So go over here, click on charts, and we can just edit the same one as before, hit edit. And then we can actually use our new data source. So go to projects, click on your cluster, and we can click the collection that we want. Awesome. So already, we can fine tune this a little bit more and make it pretty, but this already helps us visualize exactly what's going on. And as we can see, if you are going to have a negative week, then you're green, and if you're gonna have a positive week, you are blue. So we have about an even distribution for the upcoming week. We can't all be winners. In this tutorial, we conducted sentiment analysis on our CSV file to figure out whether our horoscopes are positive or negative. We then created a new CSV file that included our sentiment analysis to feed into a TensorFlow model so it could accurately predict our upcoming week of horoscopes that our model has never seen before. Along the way, we utilized MongoDB Charts to visualize our data. This tutorial was super fun to create, and I hope that you had as much fun following along as I had actually making it. And I would say my biggest piece of advice, especially when building out and using TensorFlow models, is to really go through and try to fine-tune your model to see your results. I also recommend that your dataset is balanced. This was a huge learning curve for me. When I first started doing this tutorial, I actually was only getting positive results, and I had to backtrack and figure out why, and that was because, of course, my dataset wasn't balanced. I also recommend that your data set is large enough. This was originally done on using only 3 weeks worth of data, and I had to go back and scrape 6 months worth because the data set was just tiny. For the model itself, you can always work with the layers and switch them up. You can change up the learning rate. You can change up the number of epochs. It's super customizable. And also keep in mind, if you have followed along with this tutorial in its entirety and you get different results at the end, that makes sense because, once again, horoscopes are very vague and they will be along the 0.5 border a lot of the times. So As long as you have a model that is working well, and you are learning from, that is what matters. And of course, you can apply these ideas to a lot of other use cases. Please keep in mind too, if you are reshuffling and rebalancing your data set, you will get different results every single time. If you have any questions or you would like to connect, you can find me in the MongoDB developer community, and there will be links for everything, including all of the resources I use to help myself build this tutorial, located in the description box below. Thank you all so much for watching. I hope that you enjoyed, and please leave a comment to start a little discussion about this. Check out my other information. I will include my LinkedIn in the description box as well, and you can look at all of my other tutorials if you like. Thank you so much. Bye. See you next time.